Hello, hello, welcome back after the weekend. How are you all doing today? Yes, we are back with another week of hard work and zero progress, as usual. But fear not, we have plenty of stuff to do, so there will be many more unproductive episodes. Yeah, so today we were supposed to build the MX half left. Oh, thanks for following Google Rothschild Discord 05. Cool. Yeah, so what was talking about? Yeah, we're supposed to build the MX side left part with redesigned mouse keys. So without these two keys and the whole encoder shifted to the left. Then I was thinking, okay, maybe since I already have this one built, maybe there is no need to build one more MX. How about we build a chalk version for a change, and we build one with the circuit trackpad, which is this fella right here. So I have this very cool mock-up. I was trying to get it to work some long time ago, and it stayed like this for I don't know how long. So I was thinking, okay, maybe we can build this. I have all the stuff. I have the trackpad, I have the controller, and I think it's even flashed with something. But this doesn't actually matter with what is it flashed with. And so I prepared all of the stuff to start the build. I even print all the chalk version of Chordie, and everything was fine until I got to work today. And at work I have this version. So this is Chordie, some other version that I was using at work. So if you compare this one to, let's say, this one, so this is the new one and like the recent design that I did, and this is the one from work. So you can tell that the one that I was about to build today is a little bit too high. So when I noticed that, I was thinking, okay, I already didn't like the MX version because the heights of the columns that I have used, I don't really know where they come from, which project was it. So when used with the sponge or with the wrist rest, they kind of seem to be a little bit too low. And just recently I was playing with it, so I put like a 8mm notepad under one of the halves, and that kind of made it a little bit better. So I was thinking, okay, so maybe we can change MX to make it a little bit taller. We can add 8mm to all the columns, and that will be okay. And then I forgot about this one, and I print the chalk version. And now when I look at the chalk versions, the old chalk that I was using at work, so these are way lower. So this one, I think I went for a really low profile design. So it is kind of important for Chordie to have keys at various heights, because like the way you put your fingers on, like some fingers are longer, some are shorter. So this is meant to accommodate for that, because if everything is the same height, some of the chords might be not that easy to press. So I think this design, this is like the bare minimum what we can get. So I think this one is 5mm, this one, okay, these are the same height. This one I think is just 2 point something, and this one is supposed to be the same height as the thumb keys. And you can see it's an old version because it has no infrared on this side, and it's still old encoder. So yeah, so I was thinking, okay, we still need to do some some redesign steps. I was also thinking about changing where the TRS plug will be, because right now it sits over here, and if I would like to go with this design, I think it might be a little abstracting the key, because like right now you can see the key cap is a little bit further away. Oh, hello there, Desperate Lotus. Hello, how are you doing today? Good to see you live on stream. Yeah, so this one is a little bit further, so the plug is not really getting in the way, so the key can be pressed easily. But over here, I decided to move it away from the part where the encoder is located. So now if I would like to make the column smaller, then it will be definitely getting in the way. So one thing is that I would like to try this various placements. Maybe we can get it over here somehow and see if it works or not. Maybe somewhere else, maybe here on the side. Yeah, there are some options here that we can choose from. And one more thing I was looking at. Yeah, also speaking about the sensors or the trackpads and all this stuff. Oh, no hat anymore. Left it. Too much trouble to change before the stream. Glasses and cap and all this stuff. That doesn't really make a difference. So yeah, and besides, I prefer wearing those headphones. They're much nicer than the in-ear plugs, so I can wear them for longer. Yeah, so I was thinking maybe instead of building blindly stuff, hand wiring for many hours and then being disappointed with it, I think today we will try to do a small PCB. I will show you soon how I am thinking about it, how we can approach it. It's gonna be my almost first steps in KiCAD, because I haven't done much stuff in KiCAD before. I was always using EasyEDA, which is easy, as the name suggests. Yeah, but I think KiCAD is better because like your files are your files, and you don't have to keep it in the cloud or anywhere. And it's always easier to share if anyone would like to do any changes. So KiCAD it is. All right. Yeah, and one more thing I did over the weekend. So I was talking about this some kind of diodes that would give us like how to call it, that would notify us if we have, for example, caps lock pressed or num lock pressed or some other key. And so it happens that QMK has a support for that. All we need is a bunch of diodes, whatever. I mean, we can connect anything to those outputs that QMK will be using. So this can be actually anything. It can be a buzzer even, I suppose. It will just beep. Yeah, but I decided to go with with some diodes, which I already ordered, but of course they are still on the way. Before they arrive, it's gonna take a while, maybe this week. Should arrive by the end of this week. So this is like a very rough design. I don't even know if it's gonna fit or not, if I can push the diodes through here. So it might happen that this will require some more work. But okay, going back to what we're supposed to do today. Okay, let's take a look at the whole piece. And where is infrared? Okay, it's here. Okay, let's zoom in. Right, so we need a PCB for this thing. I've been meaning to create one for a very long time. I never liked hand wiring, but it's nice if you don't really want to, you know, spend a lot of money on buying and shipping the PCB and doing all this stuff. Like hand wiring is, I think it's better for like a one-off. If you really just want to build it and forget about it, then you don't really need that much tools, and it's not that much expensive compared to ordering a PCB. So if you want to hand wire, it should be cheaper, but it takes more work, more time. Last time we've been building this for like 1 week plus maybe, so I think it took at least 6 hours, including one stream when I had to go back and redo the wiring because I used the wrong wire. But anyways, this is how long it takes. So having a PCB will be like a major improvement, should help a lot, I hope. But since both parts are different, there's a different part if we are using the trackball, there's a different, the different size if we are using the trackpad, and also there will be difference if we are using the volume encoder. But of course, there is one part that doesn't change, which is this one. So this part of the keyboard doesn't matter which attachment is being used. This stays the same. So I was thinking maybe since this doesn't change at all, it should be okay to create like a small PCB over here. Have some pins or some pads for all those keys. Have the I2C expander as well, and then we can still use these wires that we had when hand wiring, so like for I2C and for VCC over here, or maybe we can just create some additional pads on the PCB for the stuff that we need, because we can tell more or less how many additional pads will be needed. Like for example, for on the left side, I don't think we even needed this one, because from the plug, from TRS plug, we just went straight to the expander, and that was it. It was a bit different on the right side because we had to connect I2C to the MCU that was here. And then we also had to connect the TRS to I2C. So this required a little bit more connection. So only on the right side we really needed this. So my approach, I think, would be maybe we can just do a PCB that will be more or less of size of this. We can see how big it should be. Maybe we should extend the edge of the keyboard to accommodate for it. Also for the infrared, I am not quite sure right now. Of course, this doesn't really change, and there's like plenty of space. So I think we can have a piece of a PCB stretching all the way to here. Yeah, I guess we can just get to work and see where we end up. I think it shouldn't be that difficult. As I said, I'm not that proficient with KiCAD, although I did one footprint just recently. I am about to post my encoder, but yeah, it still needs some work. The GitHub repo is still not done yet. So still some work, but the footprint together with the 3D design and everything, and the symbol, everything seems to be okay. Looks good. I haven't tested it yet, so maybe this PCB will be also a way to test this footprint if it really works. Of course, for Chordie, we don't really need like a socket for the switches. Although to be honest, looking at some of those keys, like this one is quite low, but at the same time, yeah, maybe I can just open it up, because I was thinking if like there would be a couple of keys that would be like this low, and I was wondering if they're gonna reach all the way to the PCB, or are they gonna be still kind of like hanging in the air. And I think it's better to check that, because like if I decide on not making the holes and it turns out that the switch pins are kind of sticking all the way down and they will be like touching the PCB, or there will be not enough space to accommodate for the legs, that might be like a huge issue. Let's take a look. Somehow this one looks cleaner than the one we just built. Looks like less messy, but at the same time it's a little less wires. There's no infrared, there is no potentiometer over here to fix the diode strength. So yeah, it's not that bad. Yeah, okay, so anyways, yeah, so looking at it, nothing is sticking out. Maybe like this, like all the switches, everything is hidden below. Okay, so technically it should be safe to not make any holes, just make some pads. Although I might change my mind along the way. Let's quickly bring it back together. I like this one because it's very low profile. I like using it without any restress or anything like that. And it's also good for traveling, it doesn't take much space. Especially with the trackpad, it's kind of flat. It could go maybe even if it was, if all the keys were the same height, like this one. So maybe you can even go lower with this part. Just cut it in half. Because I noticed from like what I was checking before, it's good practice to have the top of the trackpad align with the top of the keycap, or like those keycaps that are around, especially this one. Because like when you're using it, so you're gonna be moving left and right, and then moving your hand to the right if you want to like press any chord. So it's good to have it like not sticking out, so your finger won't like hit even like couple millimeters. Like if I press this key, so then it will be already kind of getting in the way. So that is one design rule that I need to stick to. See, something that doesn't quite hold up. This one is meant to be dismantled anyway. Okay, so we can skip making holes. Let's make a new, let's call it PCB, new component, PCB. Okay, so let's take a look. If I remove the extension like this, will I be able to just... Okay, I can do something like this. So I can just offset the edge. Okay, let's say we make it maybe 1.2. Yeah, let's see what happens. Okay, so it's not that bad. Maybe it would be better to do like 1.3. So we will have 0.1. Okay, let's do it like this. So I think I will do it maybe 1.3. So we're gonna leave 1.2 will be like the edge. The edge will be coming from the bottom. And then 0.1 we're gonna leave just for the PCB. Although JLC PCB, I think they have a tolerance of 0.2. So that might be not enough. Let's do it 1.3. Okay, so yeah. So this will be the edge. So technically this will be part of the bottom. So we have to make it 1.6. Well, at least 1.6, because this is the thickness of the PCB. So basically we should go to the bottom. Okay, I'm gonna leave it, I'm gonna change it like this. I'm gonna make it caps lock on. Yeah, so now caps lock would become useful if I just had a kind of notification LED. The caps is on. Okay, let's call it bottom edge for now. And this will be the PCB itself. I think I did it a little bit wrong way. Oh, yeah, right, it's 1.3. Okay, one more time. Let's do offset. Let's do it 1.2, and then we can offset this by 0.1, and this will create the PCB for us. Yeah. So I will make it 1.6 right now, but later on it would need to be extended a little bit to accommodate for the bottom plate, because if you take a look, for example, the bottom plate, let's say this one. Yeah, so they kind of like one on top of another. So yeah, but this is something that we can look into later. Okay, so now let's make the PCB. Let's get over here. We can take this edge and offset by 0.1. Okay, 0.1. Okay, let's. Maybe we should do it 0.2. I am not quite confident. That's still enough space, so that shouldn't be that bad. So this way we have created the PCB itself. This is the shape for the PCB. Okay, we can remove that. Actually hide, not remove. Yeah, so as you can see, this is our PCB. This is how it's gonna look like. And I think the good thing is that we can make it reversible, so there will be one PCB for left and right, hopefully, because both parts are the same. So if we just flip it over, it should fit the other side. The only issue is that it might be a little bit tricky to get it designed in KiCAD, but hopefully it won't be that bad. Okay. So what can we do next? I think we should mark all the holes. This is something that we definitely need for the screws. So let's do it. Let's do circle. Okay, 2.9. Okay, like this. Like I think we have all of the holes from this part. Okay, then what I used to do, at least when working with EasyEDA, I would, wherever I have something to place on, like for example, over here we have an encoder, over here we have the switches, and over here there is some space for the expander, for example, and over here there should be some space for the potentiometer. Although at this point I am thinking, should we use this one, or should we maybe look for a different one, something that is maybe surface mount? Might be maybe better. I do have some surface mount ones somewhere. Okay, so anyways, so far we have only those holes presented. So for example, then like if you look at the infrared, okay, so this is the opening for the infrared. So we can, I think we can have either we can make two small holes that will fit the legs from the diode or from the sensor, something like this. So then we just like slide it in from the top, and that should be okay. But on the other hand, it might be difficult later on to remove it because let's say we slide the diode all the way in, we solder it from the bottom, and then if you want to remove it, it might be a little bit tricky to get it out because there will be no way to grab it from the top because it will be hidden inside. So we can either do that, or maybe we can just make the full opening like this, and then simply just add pads. Like for example, over here there will be ground pads, and over here there will be pads that this one will be, for example, to VCC. If it's I think the bottom was the diode, and on the top this one will be collector and all the way to the MCU. Yeah, I think that this will be better. This will give us like more flexibility. It will be definitely way easier to disassemble if we have anything. Okay, so let's do it like this. So this should be easy because I can just project this to the sketch like so. Yeah, and it's done. Okay, next thing. Should we have, for example, these parts for the resistors? Most probably it won't be much of use for us. It's a little bit too small. I mean, of course, we can solder in surface mount resistor, even a couple of them over there, and that will be fine. But we are not that much space constrained. We can do them anywhere. Most probably everything will be over here. There will be expander and every single component that we will be needing. So the resistors for the diodes and all this stuff, everything will be here. There's no need to put stuff like far away. For example, here, there's no need to keep a resistor here. So, okay. What I like to do, I like to put on the shapes. For example, like over here, I have like all the switches over here. And here I have an opening where I can put some elements on. So what I will do, I will always I will make like a rectangle for the switch, but then I would like to know where is the center of this thing. So I can do Alt Shift, and I think if I can click those two edges, and then it will show me where is the center. So over here I will just do 0.69, and this will allow me later on to align elements. If I want to align something to this particular space, this circle will help me with that. I don't know if there is a better way to align things in KiCAD. I have learned this when I was doing EasyEDA. That was like maybe the only way to get it working. I mean, EasyEDA allows you to snap to some things, so it's always best to have like a circle in the center to snap, because later on in EasyEDA, and I think as well in KiCAD, there is no way to find like a center of something, most probably. So yeah, this is what I will usually do. I will just trace this part, like how much space does it use, and then I will put a circle inside. So this way it will be easy for me to have any element aligned properly. Okay, let's do this one like this, and the same story. This and this edge, okay. Edge. This, and maybe not an edge, it's a vertex. Yeah, and same thing over here, 0.69. More, Actually, you can do these two, like so. Okay, and what else over here? Okay, and this one is wrongly aligned, so this one is okay. So we have to redo. Okay, it's snapped to the grid, and I overlooked that. Not that much of an issue. Should be easy to fix. All right, and one more. Oh, it already snapped to the correct size. Okay, let's do this one. Okay, one more. And okay. So we have all of these marked. And now I think I can also add this one. So that, okay, maybe not like this, because there is, okay, something like this. Over here, here. Okay, so we have this top part done. And now we have this region. I think I would just go with the line. Okay, let's take a look how it looks like. Let's hide it. Let's hide infrared. Okay. It looks like we are missing one line. Okay, so should be okay. Let's see what else. Have we missed anything? Probably not. Yeah, it looks like we have all the holes. We have all the markings for all the switches. Where is the center of each switch? Okay, for the infrared as well. Okay. So this is one part. So this is left one, for example, if you look at it, but then we'll have to flip it. Okay, how can we make it both ways? Okay, let's see what happens if we import into KiCAD. First, I will just drop a DXF from here. It looks like I've been working on PCB before, and I do have a design somewhere, but I think it's outdated. Let's make a new one. Maybe you can call it. I have 2 already. Okay, so let's make it 3. All right. Okay, KiCAD. What do we have here? Okay, schematic or PCB. Well, we don't really need a PCB. We don't really need a schematic, although let's make a new project. Okay, so we have a schematic and we have the PCB. Okay, let's take a look. What do we have if we jump into the PCB? Okay, so I think there should be an option to import something. Let's do this. Okay, what do we have here? Okay, so I think it should be okay to import into user drawings, and then we can change different parts to different layers over here. Okay, what else do we have? Import scale. Okay, so this is millimeters. Maybe let's make it 0.1. I'll see how it goes. We don't want to fix that. Okay, it's not that bad. Okay, so this will be our Okay, I can select different parts. Okay, so let's go with this one. Can I ungroup it? Okay. Okay, now it looks better. Would be nice if I could lock everything. Okay, now I can't. Okay, I was hoping I can lock it, so I can't move it. But I was hoping I'll be able to do some stuff on it. But looks like not. Okay. Ah, because I can also. Okay, I forgot there is this a little bit quirky stuff that I can select locked items. Can I move them? Ah, okay. So maybe this is what I wanted. Okay, let's take a look. So we have this hole over here. And I would like it to be a different layer. Where is it actually right now? Oh, okay. Yeah, but before yeah, we won't be able to flip it because this has to stay like this. Okay, so this one, I think it's called the margin or F mask. Let's take a quick look. KiCAD board. Look, what did they say? Okay, board outlines, edge cuts. Okay, this one. Oh yeah. I was hoping I can select a couple of them and change. Looks like it doesn't work. I think we are almost done with this. Okay, so it's done. But one more thing, I think we should check what are the DRC rules, so we don't end up with a PCB that we won't be able to manufacture anyway. I'm Pretty much sure they used to have a DRC somewhere. Oh yeah, this one. Let's take a look. This is the checker. This is if you want to check and if I would like to create one. I don't think that's it. Okay, here are design rules. Okay. So what do we have? Minimum clearance. What does it say? Material. Also looks like they have tolerance of 0.1. What do we have? Minimum clearance. So I guess this is between tracks. Traces. So looks like it's 0.1 millimeter. One OZ. One 152. Okay, so this will be minimum spacing, so I guess it's 0.1 minimum clearance, right? And minimum track width is 0.1 as well. Okay, minimum annular width. Okay, minimum via diameter. Where is it? Copper to edge clearance, I think it's 0.2 from what I can see. Minimum connection width. They don't have it over here. Maybe there is something already predefined. Looks like we are on our own, either way. Okay, minimum annular width. It looks like it's 0.2, assuming it's plated through hole. Non-plated through hole is what doesn't distinguish. Okay. A minimum via hole size diameter is 0.15. Okay, so I think its hole size is 0.15 and the hole diameter is 0.25. Leave it at that. Copper to hole clearance 0.25. I'm gonna change this to 0.45. Copper to edge clearance is 0.2. There's much less constraints over here compared to what they provide on the page. For example, this one, plated through hole to track, minimum is 0.5, and there is no such thing in KiCAD. I think I'm gonna leave the copper to hole clearance as default and copper to edge as well. Leave it at that. All right, let's take a look. So we have the edges of the board already. I think there should be like a 3D view somewhere. Oh, there it is. Okay. So we are getting somewhere. Okay, we have no tracks anyway. Alright, I would like to convert this. Can I just like do it like that? Okay, so if we do this as a edge cut as well, we should get a hole. Okay, yeah. I hope this is the correct way to do it in KiCAD. I don't know if there's like a different layer where we can have this. Doesn't look like it. Yeah, should be good. Okay, so we have an opening for the infrared. So now maybe we can just do the holes for the screws. I think I should have left it at 0.2. 0.1 is a bit difficult to grab. One more over here. And I think that's the last one. Take a look. Yep, looks like we got all of them. Okay. So I suppose I can't just add elements to the PCB. I think it was possible. Or maybe I can. What is this? Okay, I can add a footprint. Okay, let's see. Do we have a footprint for okay, maybe MCP 23. Oh, okay. Wrong. MCP. Okay, there is no such footprint, so I'm afraid we'll have to make one. Yeah, so now the question is, should we do it like... should we use the MCP or should we go with the cheaper one? And the one from Texas Instruments, I think. Let's save this one. Okay, so maybe we can find TCRT. Okay, there is a diode over here, so that is not that bad. At least we have one thing that we don't really need to do much about. Okay, so I think we should make a schematic for it. So it looks like it's not that flexible as EasyEDA, because in EasyEDA you can just drop elements on the PCB. You don't have to even make a schematic. So that was kind of nice. All right, so let's do a schematic. Okay, so what stuff do we have on Chordie? So we can add the diode, DCRT. Okay, how come it's not here? Oh, wow, that is odd. The diode was in... maybe I just pressed wrong button. Ah, yeah, okay, I think I pressed something wrong. How do I add how can I add a symbol? It's over here. Footprint editor, symbol library, symbol editor. Okay, what's that? Okay, I think that's the TCRT. Okay, we have it. Okay, what is that? Footprint editor. Create footprint? No. I don't need a footprint. I need a symbol. Okay, so it looks like there is no symbol for it. That is kind of... that's a little bit odd. What do we have over here? What is that? Okay, so this is a resistor. Is there like a SMD? Maybe it's surface? Oh wow, do I really have to add it myself? Okay, I think I understand. So if we add a resistor like this, so maybe then I can change the footprint, what kind of resistor it's supposed to be. Let's save it, and let's take a look at the board. Okay, so we can update this and we should get our resistor. Okay, there's an error. What is the error? No footprint assigned. Okay, so I think I am close. How do I assign a footprint to this thing? Okay, footprint. Here are inductors, transformers, crystals. Resistors should be capacitors. Why it's not alphabetical? Potentiometers, blah blah blah. Okay, resistors SMD. Okay, so I think we are getting somewhere. So what I would like to have is 0805. Oops, a little bit too big. What does it say over here? What is the difference between these two? Okay, so hand solder. So I suppose this one's a little bit bigger. Okay, that might come handy. Okay, so let's assign this one. Oh, not like this. Want a schematic. Okay, footprint over here. It's a little bit clunky in my opinion. Oh, maybe let's leave SMD 0805. Okay, so that's the one. Okay, let's see if I go to the PCB right now and I update. Okay, no errors. Okay, so we have it over here. Okay, so we are getting somewhere. We are getting somewhere. I think I should have read some tutorial on how to do it before the stream. Okay, anyways, go back to here. Okay, so for example, we have our TCRT or whatever the name was. There is no symbol for that. That is very disappointing in my opinion. Okay. So let's say that this one is 10K. Yeah, but still we have no diode anyway. Let's take a look. What does the internet say? PC 5500 at okay, looks like someone made it. Oh, there's even a step file for that. Oh, that is very cool. Symbol. Oh, that's a really nice model out there. I like it. What I think I will make my own. It's funny because there is a footprint for it, yet there is no symbol. Or I'm doing something wrong. Yeah, so if I browse symbols, analog switch. Or maybe the search is... Yeah, let's take a look. There was a footprint somewhere. Okay, it's here. Of the device. Okay, it looks like there is no symbol assigned to it. Okay, I'm afraid we will have to make our own, at least symbol. Okay, let's take a look. Want to save. What did I just save? Okay, I have my library somewhere. I would like to add it to KiCAD. Symbol libraries, migrate. Okay, I can add. I can remove this. Okay, so this is my library, and I think I can also add a footprint as well. Okay, connector pretty. All right, so let's see if I can add it the same way. Okay, something happened. Okay, let's go back and take a look if my I did the encoder so far. So let's take a look if it's available. And I called it. Okay, it's not here. Holy shit. Okay, so it doesn't search like that. Oh, that kind of sucks. Oh, so I can't really search the whole library. That sucks a lot. Ooh. So maybe we can find TCRT. Sensor optical. Okay, it's not here. Proximity. Okay, also not here. Yep. So only if I do it like this, only then I can add this to the diagram. Oh, that sucks. Yeah, so Easy Day was simpler because there was always a footprint and a symbol, and you could add it either way. You could add it either on, you could add without any schematic at all, you could just do PCB from scratch and just add different footprints and connect everything, and that would work. There would be some issues with DRC, maybe not DRC, with the nets, because like there would be no nets defined, I think, in the schematic. Okay, so does it mean that we have to create our own footprint and a symbol as well? Well, that shouldn't be a problem, honestly. Because what do we need for our PCB? Okay, we need a I2C expander, which is nowhere to be found as well. Well, I'm a bit surprised that I can't really search. I can't really search the whole thing if I do I2C. So it's not really searching everywhere. Only within this symbol. Yeah, so it depends which symbol I choose. Let's take a look. How about we check CP 017 KiCAD. Is there anywhere? No, looks like someone with the same problem. It looks like we'll have more stuff to create on our own. Okay, so looks like there will be more work to be done. Okay, so KiCAD a little bit disappointing to me compared to EasyDay. In EasyDay we would have finished already, and in KiCAD I can't even search. For example, I have my library add here, so if I try to search for my encoder, it's nowhere to be found. First I have to find a footprint. First I have to find a symbol library. Only then I can find my encoder. That kind of sucks. It should allow to search like everywhere. Oh boy, so that's gonna take a while to add everything. Okay, where should I start first? Okay, maybe let's do the diode first. Although we can technically get away with it because we don't really need the diode. We just need 4 pads, and that's all, because we won't be using the original footprint for the diode anyway. I wonder if there's something like a pad that I can add. Oh no, here it found something. But that's the footprint library, footprint editor. And that's funny because footprints I can search like that. I can just open the whole thing and I can find my encoder over here. But if I try to do the same with the symbol library, that's an editor. Okay, now I can see it here if I want to edit. Okay, I can search like this. So maybe I was searching the wrong way. Okay, so it's not that bad. I'm taking this back. It's not that terrible. Still, looks like we have to create a new symbol. How do I save it in my... Okay, symbol name, CRT. I think it's 5500 or 5000. Okay, it's 5000. Okay, as I said, maybe we don't have to really worry about the whole footprint. What I was looking for was a pad. Let's take a look on the PCB. Maybe I can add a pad over here. That's a via. think my pointer is a little bit too big. Okay, a bit better right now. Okay, do we have a path somewhere over here? Oh, yes, and all this stuff. Okay, so I guess this is a little bit different. So there is no path per se, if I'm looking at it correctly. Yeah, there's some test points over here, so maybe I could use that. Terminal blocks and stuff. Oh, that's quite nice. There are like butts for solder the wire. Connector wire, square SMD. Okay, this might come handy. Okay, but the question is there something like this in schematic? There's not much over here. It's kind of odd that there are some footprints, but the footprints have no symbols at all. Let's take a look at those pads for the wire. Okay, 2x4. Isn't it gonna be too big? Okay, it is too big. How about this one? Oh boy, it's gonna take a while. I think I'm gonna drop it tomorrow and just go with EasyEDA, just to make it fast. Because even if I look over here, okay, there's no net name. Okay, so if you make it like this, let's add the VCC. Where is VCC in this program? So let's say 10K from VCC, and this one goes to collector. Net label, I think that's what I need. How can I add a net? Okay, let's call it let's make it TCRT collector. Let's update. No errors. Okay, at least I have my encoder over here. Okay, so we can change this. So we can add this net mask for it. Okay, TCRT collector. And this should be okay, and this will go together with this 10K resistor and to VCC. get rid of this text. Okay, it's a pity that I can't rotate it however I want. If I make it like this. Let's see if I can change this part. I made this, okay. Maybe I can make my own pad. I'll add this to here. Make it filled. Okay, looks like I also can't rotate however I want. Oh. Okay, I was hoping this would go faster. I'm totally lost with this one. Oh boy. So this one I can't rotate. Is it a way to convert it somehow? At least I made it. I thought if I can make it, if I do a fillet on those lines, okay, so it's not filled anymore. All right. I think we have a lot of work with KiCAD in the upcoming week. Oh, shit. I wasn't expecting this. This is so annoying. Like compared to EasyDA. I think we'll finish on this one because it's not going too well. Either I will try to do something tomorrow, or maybe we'll jump into EasyDA tomorrow. Just do like a quick mock-up. A quick PCB, and we can come back to this one sometime later, because I really would like to have this PCB done as fast as possible, and then we can make a prototype of some sorts of one of these designs that I was talking about, and one that I could take maybe for my travel soon. Yeah, Okay. Anyways, I think that's it for today. I don't think we ever made solid progress on something. Yeah. We'll definitely be back to KiCAD. Not sure when, though. It's kind of... It feels a bit like writing in assembly. But yeah. Okay, anyways, for today, I guess that's it. Thank you very much for watching. And I see you either tomorrow or on Wednesday. Check the schedule on YouTube. The correct timing should be provided. Okay, for today, thanks for watching. Not much progress, but this is how it is sometimes. I hit a wall that is called KiCAD. Anyways, see you all soon. Thank you and bye-bye.